Hello there, welcoming you all in the physics arena by Nitesh sir. Students, hopefully you all are doing well. So, today we are going to discuss about the new chapter, which is chapter number 7, sound. So, what do you mean by sound and why it come in existence? So, first of all, we will just state about sound, what is sound and why it is come in existence. So, let's start with the topic with the introduction part. What do you mean by sound? So whenever in our daily life what we are observing that we are realizing that whenever anything just strike with any other thing, that it creates certain noise. That certain noise is said to be sound. So what do you mean by sound? We can say that in simple words that sound is a form of energy which provides us the vibration of the particle, okay, which arises due to the vibration of the particle. So let's start with the definition of sound and how it can be distinguished with the other kinds of the energy. So let's define sound. So here I am going to give you the definition that the sound is also a form of energy. Sound is also a form of energy which gives us ability to hearing. Okay, students. So sound is a form of energy which provides us the ability for hearing. Now, how the sound can be produced? So the next topic is production of sound. How the sound can be produced? If someone may ask that, sir, in how many ways we can produce the sound and what are the procedures for the production of sound? So let's start the production of sound. How the sound can be produced? Students, whenever any particle, whenever any molecule or whenever any of the substance start vibrating, it collides with its neighborhood molecule, and due to the collision there is a noise or liberation of energy takes place, which is in the form of sound. So production of sound can be achieved by the vibration of particles, or molecules gives rise collision with its neighborhood. So in this whole phenomena, whole phenomenon, energy is liberated in form of sound. Right now, students, I am speaking and you all are hearing my voice. How this phenomena happens and how this process may occur. Students, right now I am speaking. At this time, once my tongue strike with the upper part of my mouth and once it strike with the lower part of my mouth. So in this condition, tongue vibrates once upper direction, once lower direction, and it strikes with the upper and lower portion of the mouth. In this condition, there the collision takes place as I have written here. So the whole phenomena liberates some amount of energy, which is in the form of energy is said to be the sound. It means that sound is a form of energy which provides us the ability for hearing. It means that whenever and wherever there is a vibration takes place for a molecule or for a particle or for a substance, then we can say that there is a production of sound may takes place. So what is the basic difference between the sound and light? Because both are the forms of energies, types of energies. So let's start with the difference between the sound and light. Okay students, so difference, here I am writing difference between light and sound. Okay, so first of all, before going to state about the difference between the both forms of the energy light and sound, we must have to know what the propagation of sound, how the sound may propagate. Propagation of sound means that how the vibration of the sound transfer from one place to the another place. It means that it requires a medium for its transportation. That means should be liquid, gaseous, or any metal solid. So sound may propagate through the air, that is a gaseous medium. It means that propagation of sound requires any medium, that may be air. Okay students, so let's start with the difference between the light and sound. The first difference is that by definition, okay, so this is light, this is the light, and this is sound. Okay, so first of all we will give the definition. Sound is a form of energy which gives us the sensation of vision, whereas light is a form of energy which gives us the sensation of vision, whereas sound is also a form of energy but it provides the sensation of hearing. So it is a form of energy, provides sensation or ability of vision. Okay, whereas sound is also a form of energy. It is also a form of energy, it is also a form of energy which provides ability of hearing. It means that whenever there is a vibration takes place, we can hear the sound. Okay, now the next topic is speed. What is the speed of sound? And what is the speed of light? As we are knowing that in this universe the speed of light is greatest. So speed of light is 3 into 10 to the power 8 meter per second. It means that this much 3 into 10 power 8 meter distance will be covered by the light ray in 1 second, whereas the speed of sound is 343 meter per second. Okay student, it means that it is very less as compared to the speed of light. Okay, so now the next difference is what is the requirement of medium for both. As we are knowing that the sound requires medium for its propagation, whereas the light does not require for medium for its propagation. It means that from here we can conclude that light does not requires or does not requires any medium for its propagation whereas the sound requires medium for its propagation. It means that if there is no presence of the atmosphere, means that is the air, then we are unable to hear the sound. That's why we are unable to hear the voice produced by any of the person or the astronaut onto the any other planet, because on the Mars, on the Pluto, on the Jupiter there is absence of the atmosphere. That's why we are unable to hear the voice of any astronomer or any of the astronaut. So this is the basic difference between the light and sound energy. So students, sound is a wave which travels along the propagation of medium. As of now, as I have discussed to you that sound is a form of energy and which requires medium for its propagation. So for the propagation of sound, it requires any medium. It means that the air may be the medium for the propagation of sound. So sound can be termed as a wave which requires any medium for its propagation, and it propagates along the medium as in the direction of, let us suppose that if the wave or the air is moving in the forward direction, then the propagation of the sound will be also in the forward direction. That's why I have written here that it travels certain distance along with the propagation of medium. So students, basically we can say that sound is a form of energy and is also known as a wave which travels the certain distance along the direction of propagation of medium. So there are certain terms which is related with the sound wave. So what are those terms? Let's start one by one to know. Okay students, now we are going to discuss about some more topics which are related to the sound wave. What are the basic terms which is related to the sound wave? Those are termed as amplitude, time period, frequency. Okay students, so what are those terms? So the first one is amplitude. Next term is the time period and frequency. So what do you mean by the amplitude, time period and frequency for a sound wave, and how we can discuss these all factors? So let's start one by one to discuss. So first of all, I am going to give you the elaboration about the amplitude. Okay students, so here I am writing amplitude. Students, hopefully you all are aware with the displacement. What do you mean by the displacement? The minimum distance traveled by an object is termed as the displacement. So what I am writing here, I am not defining amplitude. First I am defining displacement, because in order to discuss about the amplitude we must know about the displacement. Displacement is the minimum or shortest distance. Displacement is the minimum or shortest distance, or it can be also termed as length, shortest length covered by an object. Okay, covered by an object covered the minimum distance that minimum or that shortest distance is termed as the displacement. So in order to discuss amplitude, the factor amplitude, we must know the displacement. So how we can define amplitude? Amplitude is defined as the maximum displacement, not minimum, the maximum displacement of a particle of the medium on either side of its mean position. A particle can move either in the left direction or in the right direction about its mean position. Mean position means its rest position. Then the maximum displacement of the particle on either side of its mean position is called as the amplitude of that wave. So here I am writing amplitude is defined as, how we can define amplitude, because in your examination it might be possible that we may give a question define amplitude. So amplitude is defined as amplitude for what? Amplitude of a wave. So amplitude is defined as the maximum displacement, the maximum displacement of a particle, on either side of its mean position. Its mean position means its rest position. Its mean position is called amplitude of that wave. Is called amplitude. With the help of an example, I am going to give what is the amplitude. Let us suppose that if we are having an arrangement of simple pendulum. So do you all aware about hopefully you all are aware about the pendulum onto which there is a certain fixed point to which a thread is hanged along with a bob of mass small m. In our watches which is hang on the wall, you can also observe that there is a pendulum. So there is a body or an object of mass m is tied with a string. Okay students, so you can see that at the rest condition, that bob or that pendulum will be in a rest condition. So whenever it gains some amount of energy, first it will move a bit distance. So this is maybe said to be the displacement. But if we apply the maximum energy, then at that condition it will reaches to the maximum point like this. If after the application of a force, this pendulum start to move along its mean position here and there, means back and forth, and after certain duration of time it reaches to its maximum displacement, then the maximum displacement will be like this. Initially it was here, when the time t was 0 it was here, but after time t, when the pendulum reaches to the maximum displacement, so this maximum displacement is said to be the what? Amplitude of that particle or that pendulum or that wave. So it can move in the forward direction, it also can move in the backward direction with the same amplitude, means same displacement, students. Okay, so along its mean position it covers equal distance on either side, either in the backward direction or either in the forward direction. So that maximum displacement by an object is said to be the amplitude of that wave. Okay, and it is denoted by a, small letter a, and its unit is, because it is length, so here I am writing, it is denoted by a small letter of alphabet A, and its SI unit is meter. Why meter? Because it is a length, so that's why it can be given in meters. So now we are going to discuss other topic, that is a time period. What do you mean by the time period? Okay, so by the topic it is already clear. Time period means something which is dependent on to the time. So time period is defined as the time taken by a particle of a medium to complete one vibration. Okay students, so how we can define time period for a particle? The time taken by a particle the time taken by a particle to complete one oscillation or vibration about its mean position is known as time period. It means that whatever be the time required by a particle to complete one complete oscillation or vibration, then it is said to be the time period, and it is denoted by a small letter t and whose unit will be in seconds. So time period is denoted by capital letter T, and because it is time, so its SI unit will be in second. Okay student, so till now we have learned with this diagram we can also discuss the time period. You can see here this is the mean position. So once this bob reaches to here and then it comes to here, then again it is moving here and comes to the here. So once it is going back forth, so the time taken to complete one oscillation is said to be the time period. What do you mean by frequency? The third topic is frequency. So what do you mean by frequency? So let's start with the another topic, frequency. How we can define the frequency? The term frequency for a wave. Frequency is defined as the number of vibration produced by a particle of the medium in 1 second. So frequency can be defined as the number of vibrations, because the sound can be achieved with the vibration of the particles. So the number of vibration produced by the particle of medium in 1 second is called frequency. That phenomena is termed as a frequency. So how many vibrations passes by a particle in 1 second, that number of vibrations or oscillation is termed as a frequency, and it is denoted by, and the frequency term is denoted by, it is denoted by small f and frequency, and its SI unit is in hertz. Okay, in hertz. So you can also go for that. What is the basic relationship between the time period and frequency? So let's start to learn about the relationship between the time period and frequency. Now we are turning towards the next topic, that is the relationship between the frequency and time period. What is the basic relationship between the frequency and time period? Frequency means that the number of oscillations occurred in 1 second by a particle, whereas the time period is defined as the amount of time taken to complete one oscillation. So let us suppose that if we are having a particle whose time period is t. So if capital T is the time period of a wave, so here I am writing, if capital T is the time period if capital T is the time period of a wave, let us suppose that if capital T is the time period of a wave, then with the help of the definition of frequency, then in time capital T, the number of oscillations, the number of vibrations of wave will be 1. Students, as we have given that the time taken to complete one oscillation means one vibration, that is T. So in 1 second how much vibration will take place? So in 1 second, if the time is 1 second, in 1 second, now the number of vibrations of sound wave would be, it will be equals to 1 upon T, and as we are knowing that by the definition, what we are knowing that according to the definition, the reciprocal of time period is said to be the frequency. It means that from here we have obtained the relationship between the frequency and time, that frequency of a wave can be determined by the reciprocal of the time period. It means that if we are knowing the time period by a particle to complete one oscillation, then we can easily calculate that the frequency of that wave. Okay students, vice versa we can also calculate that the time period is equals to 1 upon frequency. So this is the basic relationship between the time period and frequency to the time period. So the last basic factor which is related to the wave, that is a wavelength. What do you mean by wavelength? From here it is clear that wavelength means that the amount of distance or the path length covered by the wave in a specified time is said to be the wavelength. So how we can define wavelength? The distance traveled by a wave in one time period of the vibration of a particle of the medium is said to be the wavelength. It means that how we can define it? The distance traveled by the wave, okay, that is the sound wave. The distance traveled by the wave in one time period, it means that here T becomes 1 second of vibration of a particle of the medium is called, what it is called? That is a wavelength. It is called wavelength. So if we are willing to discuss wavelength, and it is denoted by lambda, okay, it is denoted by the Greek word which is lambda. Okay students, so LAMBDA, its pronunciation will be lambda. Okay, and its SI unit will be meter because it is a length covered. So SI unit for the wavelength will be meter because it is a length covered by the wave. Okay, so now